Hi, I'm Vikas and welcome to my channel Sci-Fi Tube. And in this video, we're going to be talking about why does an electron does not fall into the nucleus. So this is a question of physics that everybody comes across at some point. And if you have not come across this question, so let me help you out to approach it. And the reason why this question comes is that in electromagnetism, it predicts that electromagnetic radiation is emitted when charged particles are accelerated, and since an electron is a charged particle and it is being accelerated all the time around the nucleus in order to keep it in orbit, so why does it not fall into the nucleus? Well, it should, in prediction with the classical electromagnetism, emit radiation, and hence it loses its energy and it should spiral down to the nucleus, but that's not the case. It is stable, and hence we exist and molecules form and lots of things happens. So this is the way you approach the question that why does an electron does not fall into the nucleus. And once you approached it, now you have to answer it. So I have seen many videos on YouTube that no video exactly answers the question satisfactorily, but I will help to do that. So you don't need rough mathematics to think about it, or much of the concepts of quantum mechanics. All you need to know is Bohr's theory of atoms. Niels Bohr published a model of atoms with some postulates, and the most important one is the quantization of angular momentum, which is much like the quantization of energy given by Max Planck, and both are very much related, and I will show you how. So Niels Bohr says that the postulates of Niels Bohr says that electrons revolve in definite orbits called stationary states, and such states does not allow electrons to emit radiation, and in that way an electron does not fall into the nucleus. It might seem to be like this is more like an ad hoc hypothesis, but this is really not. Since we have heard that Max Planck could successfully explain the black body radiation by assuming that energy comes in discrete units, and he assumes that by thinking that all the black bodies contain oscillators, and those oscillators emit radiation in discrete quantities. So all these oscillators that he talks about is actually atoms, and since an atom emits discrete radiation, then the source of the radiation must be the electron, the accelerating electron, and that electron can only emit radiation in certain quantities, and it cannot emit a fraction of quanta of light, and the quantum of light is called a photon, and we will not talk about that in this video. So how does the quantization of angular momentum, which is related to quantization of energy, help us to think about, or help us to reason why the electron does not fall into the nucleus? So it is this postulate that is going to tell us that an electron is allowed only in such and such and such orbits, and the least orbit that it can go to is the stationary state. And in the stationary state, the energy of the electron, which is the combined energy of the potential and the kinetic energy, is quite less than the required energy to be emitted as a full photon or one quanta of light. And if an electron cannot emit one photon, then it cannot emit energy at all, and it would never fall into the nucleus, since it cannot emit fraction of photons. If nature would have allowed fraction of photons to be existed, then an electron would definitely fall into the nucleus, since it can emit fractions of photons. I mean, if light was continuous, then an electron would spiral down into the nucleus. But since radiation and electromagnetism does not come continuous to us, then it cannot emit fractions of photons. To emit one complete photon, it has to be higher than the stationary state, and it will emit one complete photon once it gets excited and jumps up into a higher energy state and then comes back down to the stationary state. So this is why an electron does not fall into the nucleus. And we can easily think about it by looking at Bohr's postulates, and we can always confirm that Bohr's postulates are not just imaginations, but those are actually in connection with black body radiation, as explained by Max Planck. And since the main answer becomes here that since electrons can only emit discrete radiation, they do not have much energy to emit one single photon once it is in stationary states. And if it cannot emit one single photon, then it cannot lose energy in fractions, and hence it is stable around the nucleus, and it will continue to go around the nucleus, having equal forces, like a centripetal force, which is the Coulombic force, equal to the centrifugal force, and it will never spiral down into the nucleus. It will never lose energy, and hence an atom is stable. And here you go, guys. I explained you why an atom is stable. I mean, why does an electron does not fall into the nucleus? I hope this explanation satisfies you, and I hope it answers your question if it had remained unanswered after seeing other videos on YouTube, because other videos did not answer at all, maybe, or maybe the creators were in confusion themselves. I don't know, maybe, or maybe I have not searched enough to get a good video. So thank you for watching, guys, and this has been my video, and now I'm going to end it. If you like it, if you like my explanation, then please hit a thumbs up for the video, and if you have furthermore any questions, then please put it down in the comment section below. And most importantly, if you want to get more answers to questions like this, to see my upcoming videos, just hit this subscribe button there, and also click on the bell icon if you want to get notified at first. So thank you for watching, guys. So see you in the next video.